Hello everyone, myself Pragna from Sri Venkateshwara College of Engineering here to present you about the topic of different phases of a compiler. What is a compiler? A compiler is a computer program that translates computer code from one programming language to the other. It converts high-level languages to machine or binary languages. The different phases of a compiler are the lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, code transformation and analysis, and code emission. This is the schematic representation of phases of a compiler. Lexical analysis. Lexical analysis, also known as scanning or tokenization, is the initial phase of a compiler. The role of a lexer is a crucial component of lexical analysis phase where it reads the source code character by character and groups characters into token based on predefined rules. The token types are keywords, identifiers, literals, operators, punctuations, etc. Lexical rules and tokenizing process are some of the components of lexical analysis. Syntax analysis. The syntax analysis phase, also known as phrasing, is a crucial step in compilation process performed by a compiler. Here are the key aspects and concepts associated with the syntax analysis phase of a compiler. The lexer, the grammar, the phasing, the syntax tree or AST, error handling, intermediate code generation, and ambiguity resolution. Semantic analysis. The semantic analysis is the phase in the compilation process that follows syntax analysis. While syntax analysis deals with structure and grammar of the source code, the semantic analysis focuses on the meaning and interpretation of the code. It, Here are the key aspects and concepts associated with semantic analysis. Symbol table construction, type checking, scope resolution, declaration checking, function overloading and resolution, constant folding and propagation. Control flow analysis, error detection and reporting. Intermediate code generation is a crucial phase in the compilation process that comes after the syntax and semantic analysis phases and before the code optimization and code generation phases. The definition of intermediate code is an abstract code that is more expensive than the source code's syntax but less detailed than the machine code. The advantages of intermediate code are simplicity and machine independence, and translation of high level constructs, handling of expressions and control flow representation, generation of symbolic address, debugging and error handling and reporting, target independent features, procedure calls, and optimization of opportunities. Code optimization. Code optimization is a crucial phase in the compilation process that comes after the intermediate code generation phase and before the final code generation phase. The types of code optimizations are machine independent optimization, machine dependent optimization. The common code optimizations are constant folding, common sub-expression elimination, dead code elimination, and loop optimization. Constant folding evaluates constant expression at compile time. Loop optimization optimizes loop for better performance. Inlining replaces a function call with the actual code of the function. Data flow analysis analyzes how data value propagates through the program. Common sub-expression elimination identify and eliminate redundant calculations. Dead code elimination removes code that has no impact on the program's output. Register allocation assigns variables to the registers for faster access. The last step is the code generation. The code generation is the phase in the compilation where the intermediate code is translated into machine code or assembly language, making it executable on the target machine. These objectives are translation to machine code, optimization, memory management. Key activities consist of instruction selection, register allocation, address calculation, and code emission. The code generation in action is the instruction selection that translates arithmetic operations in intermediate code to machine instruction. Register allocation shows how variables are assigned to registers. Address calculation illustrates how high level data structures map to machine level memory addressing. Code emission displays minutes of generated machine code for a simple program. Debugging and profiling briefly touch on embedding debug information for debugging. Considerations for profiling and collection of color runtime performance data. And this is the conclusion. The lexical analysis and syntax analysis breaks down the source code into meaningful tokens. The semantic analysis ensures the meaning of the program is correct. Intermediate code generation creates an intermediate representation of the source code. Code optimization improves the efficiency of intermediate code. Code generation translates intermediate code into machine code. Linking and execution combines multiple object files into a single executable form. Thank you.